Hello and welcome to 8.2 Integration by Parts. So here we have our integration by parts formula. This is really a formula that's based off of the product rule. Just rearranging it. You have the two versions, typical version that we all know are what we have here, the bottom one, the differential version. uv minus integral of v du. One thing you want to make sure you're doing when you're solving any of these integration problems is to know which one's going to be u and which one's going to be v prime, because those are important. Okay, so u is generally something that can be differentiated repeatedly. So think of u as something that can be differentiated repeatedly, and if possible, you keep differentiating it until it can get to 0, if possible. And then our v prime is something that can be integrated repeatedly. Okay, and that should be something that we could integrate rather easily. Okay. So let's take a look at our first example. We have to say, define the integral of x cosine x dx. So we figure out what we want to set equal to u, and we want to set equal to the integral of v. So we're going to say that u here is going to be x, and our dv is equal to cosine x dx. Okay, so if u is equal to x, that means du is equal to just derivative of x is 1 dx. So we just say dx. And if dv is equal to cosine x dx, and we take the integral of dv to get v, well, the integral of cosine x would be sine x. Okay, so to set this up, we're going to do, in general, we're going to have u v minus integral of v du. Okay, so for our purposes, uv would be u, and u is x, and v is sine x, so x sine x minus integral of v sine x du, and du is dx. Okay, so we have x sine x, and then we have integral of sine x Now integral of sine x would be negative cosine x, right? But we already have a negative in front, so that negative and that negative will cancel, make it positive, so we have plus cosine x plus c. Don't forget the plus c. Okay, and that would be it. Let's take a look at another example. Find the integral of ln x dx. Okay, so for this one, we will say that let's have u equal to ln x, and then for dv, that will just equal dx. Okay, so that means when we get du, this will equal 1 over x dx. And when we integrate dv, we get v equals x. Right, because we're really integrating like a 1 here. So when we integrate the 1, we get x. Okay, so we have uv. So uv would be ln x times x. I'll put the x in front. So x ln x minus integral of v du. So x 1 over x dx. Okay, so we have x ln x minus integral. Now x times 1 over x is just 1. So we have x ln x minus, integrate the 1, so we get x, and then plus c. And that would be the final answer. Okay, let's take a look at another example. Integral of x squared times e to the x dx. Okay, so we could set u equal to u could equal x squared, and then dv would equal e to the x dx. So if we take the derivative of u, we get 2x dx, integrate the dv to get v, and we get e to the x. Okay, so now we can do our integration by parts. uv, so uv is x squared e to the x minus integral v du. So e to the x times 2x dx. Okay, so we have x squared e to the x minus integral. I'm just going to rearrange this a little bit, so it's 2x e to the x dx. So it doesn't help us, but it gets us a little bit closer. So here's a case where we're going to have to do integration by parts again. Okay, so we'll repeat the process. We're going to do integration by parts for our integral here. Okay, so our, another set of u's, another set of dv's, and we go on from there. So let's say u equals 2x, dv equals e to the x dx, du would equal 2 dx, and v equals e to the x. Okay, so we still have the x squared e to the x minus So I'm going to put this next part in parentheses. So we have the uv, so 2x e to the x minus integral of v du. So 2 e to the x dx. Okay, so now we could simplify a little bit. We have x squared e to the x. We have minus 2x e to the x. And then we have a minus of a minus, so that's plus integral of 2 e to the x dx. Okay, now integral of 2 e to the x dx would just be itself. So we have x squared e to the x minus 2x times e to the x plus 2 e to the x plus c. And that would be the final answer. Okay, let's take a look at another one. So here we have integral of e to the x cosine x. So let's say that u is equal to e to the x, dv is equal to cosine x dx. To get du, we'll get e to the x, integrate dv to get v, integral of cosine would be sine. Okay, so that means when we do the integral, we have uv, so e to the x sine x minus integral of v du. So that would be e to the x sine x dx. Now one of the things that you'll notice here is for a problem like this, remember in the beginning I said choose the u so that as you differentiate it, it gets simpler and simpler, goes to, it'll go to 0 as you differentiate repeatedly. And then, well, here the u is not going to do that. You're still going to get e to the x no matter how many times you take the derivative of it. Okay, so this problem is going to involve something a little different, a slightly different technique. Okay, so I'm gonna show that to you guys as we go through it. Okay, so let me just summarize here. We have integral e to the x cosine x is equal to e to the x sine x minus the integral of e to the x sine x dx. Okay, so let's do integration by parts again for the second integral here. Okay, so I'll set u equal to e to the x, dv will equal sine x, So that means du will equal e to the x dx, and v will equal, that would be negative cosine x. Okay, so we have the integral of e to the x cosine x equals e to the x sine x minus, so now we're going to replace this integral. So I'll put parentheses here, uv, so we have negative e to the x cosine x, so that's uv, minus integral of v du. So that would be negative e to the x cosine x dx. Okay, so now notice what happens. Let's distribute the minus sign here so that we don't have all these extra minuses hanging around. So I have integral e to the x cosine x equals e to the x sine x. Now minus of a minus, that would be plus, so plus e to the x cosine x. So now we have minus of a minus, that would make it plus. And then this minus we could pull outside. We have integral of e to the x cosine x dx. Okay, so now notice this is the technique. So notice we have the same integral appearing again. Right? It's almost like this never-ending loop that some of you computer science majors encounter from time to time. Right? Those infinite loops. So you have this integral appearing again. Okay, and this is what we started with. So the technique is this. We could add this integral just like an equation. We're going to add this integral to both sides. So we're going to add that there, because when we add it to the minus, it's going to cancel itself, right? It's going to disappear from the right. Add it to this side. Okay, so now when we add it to the left, that means now we have two of these integrals. Right, so we have 2 integral e to the x cosine x equals e to the x sine x plus e to the x cosine x. And then the last step is we're going to divide both sides by 2. Right, we're going to divide both sides by 2. These 2's will cancel. So we have the integral of e to the x cosine x equals, okay, we got this quantity. All we're going to do is add a constant. This is an indefinite integral. Okay, and that would be the final answer. Okay, So let's take a look at what happens when we have a definite integral. Okay, so our formula for a definite integral, we evaluate the uv part from b to a, and then we integrate like normal the v du, and of course we have that on an interval. And then when we're done integrating that part, we plug in there as well. Okay. So it says find the area of the region bounded by the curve y equals x e to the negative x, and the x-axis from x equals 0 to x equals 4. And here's the graph of it on the right. So we're finding the area underneath that curve. Okay, so the basic problem is if we set up the integral, problem will be from integrating from 0 to 4 of x e to the negative x dx. Okay, so let's let u equal to x and dv equals e to the negative x dx. That means du would equal 1 dx, or just dx, and then v will equal, when we integrate this, that would be negative e to the negative x. Okay, so let's do our integration by parts. So we have uv, so x, and that's a negative, so negative x e to the negative x, and we're going to evaluate that. So we got uv minus integral of v du. So that would be negative e to the negative x dx. Okay, so here when we plug in our 4 and our 0, that means we'll have negative 4 e to the negative 4 minus 0 e to the 0. Now here, this negative will come outside and make that a plus. So we integrate from 0 to 4 of e to the negative x dx. Okay. So now we have our negative 4 e to the negative 4. This one becomes 0, right? 0 times anything is 0. And now let's integrate this. So when we integrate e to the negative x, well, that gives us negative e to the negative x. And we got to evaluate that from 4 to 0. Okay. So now what we could do is, because it's plus and negative, we could just say that that part is minus. And then we're going to do e to the negative 4 minus e to the negative 0. Okay, so we have negative 4e to negative 4 minus e to negative 4 minus well, e to the 0 is 1. So if we distribute the minus sign here, that's negative 4e to negative 4 minus e to negative 4. Minus of a minus is plus. Now remember, these are both have e to the negative 4, so you really have a 1 here. So if you have negative 4 minus 1, that would be negative 5 e to the negative 4 plus 1. And you could leave it like that. That's perfectly fine. If you evaluated it, if you put it into a calculator, you would get something like 0.91, and that's okay as well. Okay. Any questions, just let me know. Write me an email. Have a good day. Have a good night. We'll see you soon.